Yes, before starting, I just introduce you.
Yeah, exactly. Kade sir, you please go ahead.
Yes, sir. Yes. Good morning, all of you. On behalf of Sharad Institute of Technology, College of Engineering, I welcome Honorable Ian Prakash Sir for this second phase of STTP on energy conservation and audit. In this session, he talk on best practices in textile humidification system and energy conservation case study. Uh, c- he completed his graduation in a mechanical engineering from MIT and MTech in thermal engineering. Currently, he is working as a CEO and director of Vayu Techno Engineers Private Limited. He has membership of number of professional bodies such as ASME, ASHRAE, MIE, ISHRAE, ICC, ECI, and so a number of professional bodies. He is also vice chairman of Indian Institution of Plant Engineers. He worked as a governing council member of Indian Institution of Plant Engineers. He is executive committee member of Institution of Engineers and general body member of Engineering Council of India. He provides consultancy for industrial air conditioning, ventilation, air pollution control systems. Also, he involved in analyze of that systems for performance, energy efficiency, design, manufacture, supply, testing, and commission of new systems. Also, he give advice on project planning consideration uh, of individual product life cycle, energy efficiency. He also conduct a site visit for technical study and he extending services for evaluating the performance and upgradation and expansion of that particular uh, system. He also involved in the plant audit for improving efficiency and energy savings. He has 30 years of experience and he associated with Batley Limited, Souther AG Switzerland and Binny Limited companies in engineering projects, installation, operation and maintenance of that central air conditioning, humidification and ventilation systems. With this brief introduction, I request Prakash sir to start his session. Thank you, sir.
Yeah, thank you so much. Am I audible?
Yes, sir.
Yes,
Yes,
you
you
are
are
audible.
audible.
Yeah, first of all, my thanks to Dr. Sanjay Kot and his team of professional engineers who are all coordinators for this wonderful program, short-term training program on energy conservation and audit. Thanks for giving me the opportunity. So I'm just going to talk about the textile humidification systems. So here, actually, we are facing power cut. Actually, I am in. There is a power cut. Just I'm working on UPS. If you don't mind, I can switch off the camera. See, the cotton and the man-made fibers in textile manufacturing process like spinning, weaving undergo series of operations in production process, and due to the properties of the raw material and hygroscopic nature, they are subject to contamination, high level of fly liberation and micro dust. So the manufacturing process, textile manufacturing processes have various requirements in the indoor environment conditions, like maintaining relative humidity, temperature, dry bulb temperature, and air changes, uh, which are all the required best conducive atmosphere for the higher production and quality. So basically, new generation textile machines are designed to work at high speed, but due to the inconsistent and variation in the inside ambient temperature, it restricts the high speed and also create associated problems in the damage of electronic devices, controllers, etc. So mechanical properties of the fibers and yarn basically depend on the environment conditions, on the temperature and relative humidity. So dry air may lead to lower the regain of fibers and attribute to the poor quality and the low production efficiency, and on account of frequent yarn breakages, that is the yarn strength reduces, it frequently breaks. So basically, air conditioning and humidification systems consume high energy in the textile manufacturing plant, and its efficient utilization becomes a paramount importance, as the energy cost in the manufacturing cost of textile is about 12 to 15%. So productivity and the quality are given priority in the competitive market, as you all know. The best working environment, precise inside conditions of the priority nowadays. So more focus on the operation maintenance of the humidification plant, its airflow and its volume calculations, how the ducts are designed, how the insulation is taken care, how the infiltrations are avoided, how the air changes, air balance, what is the impact of supply air and exhaust air in the total systems, and how the trenches are all designed, how the it matches with the latest modernization of the machine if it is a retrofit project. So all these things are important in to know about the energy aspects as well as the textile humidification system. So we are going to just I'm going to explain about the basically about the basics of humidification and what are the limitations in following the psychometric principles in the operations, how to utilize the heat and other sources, and the areas of improvement, and of course energy conservation. I will show one study also. So basically in textile manufacturing, there are certain norms to maintain the relative humidity at different levels in the different processes, like from opening and picking in the spinning factory, start from the opening, carding, silver lapping. So they have given us for RH for cotton from 45 to 60, like various departments. You see in spinning 45 to 60%. It is a broad range. It depends upon again the raw material, what count and what speed they operate, or based on that the recommendation is there. So same way for man-made fibers also recommendations are there. This is about relative humidity. Same way we have for temperature also. Minimum temperature has to be maintained at various processes, from right from blow room to carding, spinning. So 27 degrees is the minimum temperature. Maximum temperature 33 degree centigrade for the cotton mixing, and for spinning it can go up to 35%. Like that, norms are there, recommended temperatures are there. If you operate within that, you will get the required quality, productivity, everything. So dust concentration level also more in the textile manufacturing. So model factories are expected to maintain hygiene indoor air quality in the production area, and the mill also should not cause pollution to the atmosphere. So the dust concentration level should be as minimum as possible. Of course, this is the OSHA standards. We are not that much implementing it, but it's the OSHA standard. For the purpose of academic interest, I included that in the chart, the table also. So for blowing and rolling preparation operation, 500 milligram per cubic meter is allowed, dust concentration limit, dust in the air stream. For spinning, twisting, and winding, about 200 milligram per cubic meter are allowed. For sizing and weaving, 750 milligram per cubic meter are allowed. This is OSHA standards. Of course, we don't have such standards, but still it is better to maintain that standard. So also there is recommended air changes. The air changes explanation I will give later on, but it is like changing the your total air in the production hall number of times in an hour. So entire production hall will be replaced with new air in 1 hour time. That is called air changes. So in blow room, carding, all the places, it's about 10 to 15 air changes. In spinning, about 25 to 40. Of course, nowadays it is also due to the speed of the machine. It is also it has also been increased to 45 till 45, 48, and all it goes. Winding also 20 to 30. Other twisting, warping, sizing, weaving, and all about 30 to 40 air changes per hour. So to understand this, basically we need to know what are the layouts, what are the machines in the textile chain. Basically, it starts from blow room. It's a large size and it occupies a very good space. and more dust and more fluff and more micro contaminants. Everything is there in the starting department, that is in blow room. It is more there. So this information I am giving to know how the plant has to be sized, designed, and how we have to take care of the plant. So in spinning preparatory, that is including carding, comber, everything. So comparatively, it is smaller, but layout machines are smaller. Layout is big and large volume. It has high dust and fluff. Heat load comparatively less. Machine motor kilowatt less compared to blow room, and other spinning also. So if you take spinning textile machinery, spinning is a large and occupy more space, more kilowatt, and it generates more heat, dust, fly liberation, everything is more. So once everything is generated more, obviously we have to maintain better inside condition. Heat also generate more, so we have to dissipate that heat and maintain the required RHN temperature as per the recommended RHN temperature. So in winding, it is sizes or machines are medium and less heat compared to your spinning, and dust level also very less. But we need to maintain a higher RH and lower temperature here compared to spinning, because it's a process of if you take as a only spinning mill, this is the end process mostly, almost. After winding, packing, or yarn conditioning, it will close. So if you take a weaving plant, of course the sizes are medium, heat generation is very low heat because of the kilowatt of the motors and all very low, and dust and sizing powder dust is more here because of the warp. They will add the size powder in the warping. So that will, once the weave starts, that powder start falling. So that problem will be there. So that dust will be more. So that has to be removed. So this is the basic textile industry. So knitting, if you take knitting also medium size it is, and it also generates low heat only. So how the how heat is generated, as well as what is the load on your textile plant. Basically, we have we can demark as a climate, weather, and seasonal changes. Climate is the average of a weather. You have over a period of time you collect all the data, it become a climate changes. And weather is that particular day, what is the weather condition. And seasonal changes is you have monsoon, summer, winter, like that it changes. Due to all these effect, you have a different RH and temperature, dry bulb, wet bulb, all keep changing, and also based on your location of your factory, be it in which zone it is. So in India, if you take, you can see different zones. You can see in a map there are dry and hot and dry zones. You can, next slide you will see a map. It is colored red color and all. It's all hot and humid climate. And hot and dry, you can see yellow color. It is most part of the Rajasthan and other western region. And you can see composite climate, Delhi and the other area, composite climate. That means both extreme you will get it. Dry also is more dry bulb temperature maximum also you will get, minimum also you get. Sometimes it will be 10, 12, 5 like that also. Maximum also it will reach 45 like that. So that is why it's composite climate. And cold regions are some of the regions. In some places you can extreme cold will be there, like higher altitude it is there, means they'll cold regions. And moderate places are there somewhere like Bangalore and other places. These are the zone climatic zones of India. So just this broad classification, based on that you can at least visualize it is not equal all over India. for a spinning factory. If you are running a plant of 25,000 spindle, it may not be same for all locations. If you see, you can classify from a psychometric chart what is a hot and humid climate. Based on the temperature graph, it will differ. Some place it will moderate, warm, everything. So if you the inside conditions totally based on your wet bulb temperature. What is the wet bulb outside temperature? Because as per psychometric principles, only humidification plant is working. If it is a fully air conditioning, you can run at any dry bulb, any wet bulb condition. But here in most of the textile mills, 99% of the mills, we work on only evaporative cooling. That is without refrigerant, only with water we spray and get the conditions. So it is all based on your wet bulb temperature, outside wet bulb temperature, and also the coastal zone, river, lake also add to your wet bulb. Like in a coastal region, it will be more moisture, like Mumbai and Kolkata, Chennai, and other places where it is a coastal region. You can see more higher RH. Whereas Vizag and all, whereas in dry cities like Hyderabad, Madurai, Delhi and all, wet bulb medium, dry bulb, only dry air you can see. In Coimbatore and all, you can see moderate dry and wet bulb low places. So irrespective of the outside conditions, we need to maintain the required RH and dry bulb temperature in the manufacturing. So from the basically it is this is the psychometric chart. From the psychometric chart is the what is the condition, outside condition, what is the achievable condition, and what is the maximum efficiency we will be able to achieve in the plant, and what RH and temperature we require. Based on that, we can find out what is the moisture content in the air, grams per kg of air. That is only more important in the textile manufacturing. The grams per kg, that matters very much in the yarn weight and other your other parameters in the process. So in the psychometric chart, if you know two parameters, other things you can easily find out. If you just buy a whirling hygrometer, dry and wet bulb hygrometer, if you just check the dry bulb temperature and wet bulb temperature, other things you can mark in the chart and find out what is the moisture content in that air. So that plays an important role for the quality and everything. So for the plant will be operated based on your humidification, that is psychometric principles. There are 8 basic psychometric principles. Heating, generally heating, when the temperature is outside, temperature is in winter, it is low. You have to maintain minimum 32 degree, whereas outside there could be 7 to 8 degree will be there. So you have to heat, generate the heat in the factory so that you will maintain the temperature. Same way, when the outside RH is very low, you have to increase the RH in order to maintain the required levels of different processes. So same way, when humidity will increase as well as decrease. So you have to manage everything. So these are the 8 different processes. In the next slide, I will be showing this. If it is sensible heating, and if you go towards left side, it cools. It is sensible cooling, and it is humidification. It is dehumidification. You have to dehumidify the air, reduce the moisture. It is dehumidification. At the same time, parallelly, 2 things will happen: heating and humidification also happen. Cooling and dehumidification happens. Cooling and humidification happens. That is mostly you have to cool the air as well as humidify. Mostly in dry region in summer, you have to do that. Heating and dehumidification, you have to heat the air as well as reduce the humidity. These are the process. But generally, why I am telling all these things is, if you know the process and what is the requirement of your if your mill or customer or the stakeholders, then you can analyze where it is going wrong. So this is the process I already explained. So you need to know what is basically relative humidity. So it is the moisture, it is the mass of the moisture, water vapor in the air. It is a comparison. For example, in a 20-degree air, the water content fully saturated, it will be 14.6 gram per kg. That is dry bulb and wet bulb both will be same. That means saturated condition. When you see in your hygrometer, both dry bulb, wet bulb same, That means fully saturated condition. Maximum 100% RH it is holding. Maximum RH. So saturated condition. So for an example of 20 degrees centigrade, it is holding 14.6 gram per kg. Same air when at is 50% if the kg is holding 7.3 kg, it is 50% RH only. Same 20 degree, it will be holding 50% of the air. That means 7.3 grams of water vapor only is evaporated in the air. That means grams per kg is less in 50%. It is more in 100%. This is what water vapor. Basically, it's water vapor. What is the amount of water vapor available in the air? That is only relative humidity. That only react with your hygroscopic nature of your material. That is basically cotton, mostly cotton. So I'll just this is water. So 10% humidity means it will be look like this in a volume of air, 1 kg of air. If it is 95% relative humidity, it will look like this. You imagine that as a water vapor in the air. It will resemble like this. This is imaginary one. So basically, what is the air conditioning humidification system in your textile plant? So we have basically an air washer chamber, and air will be circulated through the air washer chamber. Water will be sprayed there. And the air and the water molecules will mix. It will atomize, and then only air will come out. Water will be eliminated in the water droplets. Only air will come out. That air, after the air will have the temperature down. It will be temperature will get cooled, and humidity will increase after the eliminator. That air will come to the inside. So this is the schematic diagram. If you see, this is the circuit. You have a written air duct, supply air duct. The fan is there. From washer room, air is going to the supply air duct. So this is the plant. Inside you are maintaining temperature of 25 degrees, 60% RH, and written air duct air is going. Hot air is going and got filtered, and it is going through the written air fan and going. It is being sent to exhaust into the atmosphere. Whenever the inside temperature drops down, then it can be recirculated. So it can be recirculated. Hot air is again taken inside. So you need to know the how it functions. Basically, fresh air is taken first, it's filtered, then brought into contact with the wetted surface with the spray of waters and droplets, and then it gets cooled, humidified due to transfer of sensible and latent heat between air and water. And cooled air is supplied to the conditioned space. It picks up the heat there. Already there will be heat. It picks up the heat, and you will attain a particular temperature and RH. This process totally follows adiabatic saturation. So there is no change in the wet bulb temperature. It follows the constant wet bulb path. So saturation efficiency, it can reach 95%, even more. But again, there is a cost involved with that to reach the maximum efficiency. Uniform spray, as well as what is the amount of water you spray there, evenness, velocity of speed of the air going into the chamber, it all matters. Then you can attain the higher RH. As Setaram sir was, Ashok sir was filling, even though you achieve that best RH after the air washer, your distribution losses are there. You are not taking it inside. Distribution loss will be there. First of all, you have to create this maximum RH. Our motto is to create best efficiency. So I will explain all those things. So in the chilled water system, that is what I was explaining earlier was a normal water what we are using for the spray chamber. If you are using chilled water, that means involving refrigerator compressor and your evaporator, water cooled condenser, everything will be there. So there is going to be a power on that. So the water will be chilled, and that chilled water will be circulated in the air washer. So irrespective of the outside dry bulb, wet bulb, whatever the wet bulb condition, wet bulb and RH conditions, throughout the year, if you want to maintain all-round air conditioning for the entire year without any disturbance, then you have to go for chill water air washer. So that is become all-round air conditioning, but it is used in certain places. But it improves the textile machine life, as well as disadvantage is high investment and more power, and the maintenance are more. So if I if I explain into the conditioning of the functioning of the equipment, so functioning of the equipment, if you go, basically your whatever the dust generated, that has to be first filtered. That is what our requirement in the production process. So there will be a lot of dust accumulated, floating fluff, fly liberation, everything will be there. That has to be filtered. So that for that provision should be there in the our air conditioning station. For that we have a air filtration filters arrangement. It will arrest the dust filter, and different type of filters are used. Nylon filters are used. Some places synthetic non-woven are used. Polyurethane foam media is used. Acrylic fur material are used. And you have different type of filters, stationary and rotary filters. The advantage of rotary filter is uniform condition. You can have always, it will be cleaning, so that there is no inequality in the dust level in the production hall. Whereas stationary means it will just come and hit the stationary filters. Somebody manually, it has to be cleaned. So that delay will create problem. So motion of the air, how the air moves inside your distribution, as already explained, distribution, how it is to be distributed through the fan, axial flow fan. We'll go to the fan later. So large volume of air at low pressure, axial flow fan are used. How it is distributed, taken inside. So temperature control, how it is done in the air washer, how the outside verbal maximum, how it is controlled, your temperature controlled by the through damper control, and RH is controlled by the recirculation of the water with the pump system. The RH is increased or decreased. It can be increased, but decreasing again, you spray less, it will with less efficiency it will work, and your RH will you will get less. So these are the equipments. We have the axial flow fans. It will be axial flow fans, and different type of fans are there. I'll explain next after a few slides. And we have an air washer chamber, spray chamber will be there. The nozzles will be there. It will be evenly distributed, and per square feet, this much nozzles are there. Some calculation, design calculation, based on that it will be working. And there is no gap. There is no air doesn't escape from the water. It should be sprayed, distributed such a way, spread such a way, so you'll get good efficient air washer. So I think Ashok sir has shown that water are oozing out without much spray like that. That problems were there. So that problems and all, if it is solved, so you will get a good efficient pumping system, which will the energy will be properly used. So this is the air washer. You have the tank and you have the spray pipes. This is the what eliminator I was telling. It will eliminate eliminate all the water droplets. Only it will allow the air to come out. This is the different type of spray chamber inside. The next slide, you can see the spray chambers, water spray nozzles, and this is the air damper. Through damper control, we can control the air, total air. How much air, fresh air has to be taken, how much return air has to be taken, how much bypass air has to be taken, how much air to be exhausted. All these things can be decided by the control of damper, closing and opening. And this is the air intake lever. You just go through this air intake lever. This is the lever arrangement where intake we have given this evenly distributed air will be even. See, as the fan is working, the airflow will not be straight. There will be a turbulence in the airflow. So it will be wherever the due to the velocity of the fan, it will just turbulence will be created and it will move zigzag. So to avoid that and make a uniform distribution, the spray chamber, this air intake levers are given so that uniformly the air will flow inside the spray washer and escape through the eliminators. That the purpose of this is to make the spray mixing proper. So because my one of the case study going to be that's why I'm spending time on this. So this is the eliminator, water drop eliminator. Water drop eliminator totally eliminates the water after the from the inside the chamber. So how it is happening? You can, next slide I have shown the curvature of the particular eliminator. So the from this end, from left end, it goes towards right end, the air and water. That due to that curvature and profile, the water gets dropped. So there will be many eliminators. It will be fixed. Either side there will be eliminators of 20-25 mm gap. Many eliminators will be fixed, and air and water mixture will go inside, and the water will get dropped. So So this is the air distribution through the air duct. It is delivered inside the your factory. This is a weaving plant shown. And of course, on the underground trenches, we have underground trenches wherever the hot air, machine exhaust, fluff, fly liberation, everything to be collected through the underground exhaust trenches. We have trenches, and all those things. The trenches will be connected to a rotary air filter. So rotary air filter, dust laden rotary air filter, entire air will come to the rotary air filter. Nozzles will be moving in the rotary air filter. So nozzles will be collecting the nozzles will be moving will be moving when the drum is rotating. Nozzle will be moving. So all the accumulated waste will be collected through the nozzles, and it will be transferred to the cyclone dust collector and screw feeder. All the waste will be get collected. This is the cyclone system. In the cyclone system, both air and waste will come inside due to the cyclonic effect. And due to the cyclonic effect, it will will happen to the air, and due to the weight and density of the waste, it falls down at the bottom, whereas air will escape through the center pipe. Air will, after giving a circular movement, air will escape through the center pipe. So all waste will get accumulated in the bottom chamber. There you have a screw feeder, and motorized screw feeders are there. Earlier they used to have collection bags. So manually they used to collect with a bag. So nowadays we have a screw feeder. So it will compress volume of waste will be compressed, so that in compressed form it comes out. So continuous waste will be collected here, as well as continuous collection of dust from the rotary filter. Because the continuously waste are collected in the rotary filter, your air, whatever is collected from the department, it is getting cleaned totally. All the waste are collected through the return air systems. So it is a continuous working, so that you will be able to maintain the required conditions inside the dust free situation in the production hall. If you see basically the humidification plant will have two separate systems. That is, one is a supply air system, which consists of the some dampers, fresh air filters, fresh air dampers, then louvers, air washer chamber, then eliminators, consists of eliminators. Then you have a fan and duct. So that supply air quantity will move from the supply air in the top side. We have a duct distribution, and it will be delivered in the top side. Whereas the exhaust system, it will be mostly underground exhaust system. Through underground exhaust system, through the floor grills, and through floor grills and slit grills, as well as machine exhaust will be there. We have pneumophile exhaust. We have technology air in the OE machines. You have compact air. All this air will be taken through ducts, and it will be collected in a underground trenches. So underground trench is connected to a rotary filter, cyclone system, and again to a exhaust fan. So this supply air quantity and exhaust air quantity, there should be slightly difference. That is, supply air should be slightly more than the return air system. That is, return air should be less. 95% only of supply air it should be. Why? The reason is, so it will create a positive pressure inside your department. It will create a positive pressure, so that outside infiltration air doesn't come inside your conditioned space. So more positive air is there. Slightly air will leak outside. That is not a problem, but slightly it will leak. So that is better. So conditioned air slightly escape, but that is better. But due to the working, it will get balanced. Sometimes some machine will be on, some machine will be off, some fans will be switch off. Like that condition will happen. So whenever it is exhaust is more, it becomes a negative pressure. It try to take from outside air. For example, in winter season, you're trying to maintain 32 degree, 34 degree centigrade in inside, and suddenly your exhaust is more. and from other windows and openings, it try to take outside air, which will be chill. If it is a 10 degree or 5 degree outside, it will try to take the outside air, so you will not be able to control the drivable temperature inside. So that is the reason exhaust is given less, supply is more. This air balance is very important. Without air balance, you will face a lot of fluctuation and problems in the production. At a stretch in the textile mill, at a stretch, there will be a problem in the production. There will be sudden stoppage of 4-5 one side. Suddenly they will be start up 4-5 machine due to this fluctuations. This kind of problem will happen. So the air changes, what I was telling, this minimum recommended air changes to maintain that. So what is air changes? Supply air quantity per hour, meter cube per hour divided by volume. Volume in length, breadth, and height of your production hall. There will be fall ceiling. Below the fall ceiling to floor level, what is the height? And what is the width of department? What is the length of department? That that consists of volume. So supply air quantity divided by volume, you will get air changes. So mostly in spinning it will be more, weaving it will be more. In other department it will be slightly less based on the recommendation. This is the air supply air quantity and air changes. So here in the energy point of view, the recommended air changes will be there. We have to see the plant performance as well as the air changes. If we are going as per the heat load, you are designing the plant of certain air quantity, meter cube per hour something. If it is not performing and your air changes, you are asking for more air changes. That means you are supplying more air into the production hall. That means you are more power you are using in order to maintain higher air changes. So what is the optimum air change? That you have to see particular case-to-case basis. In any factory, you have to see what is the production rate, what is the speed of the machines, and what are the your back process, what is the material flow. Based on that, you decide on the air changes. Just blindly people say, I want this, if it is spinning this much air changes. That is not required. So in the particular, it is not that you have one mill in the north, same thing be followed in the south also. It is like that. So based on your raw material, your material movement, and your speed of the machine and your production process, all these things only you design on the air changes. It is only a general guidelines air change is given. So some type of raw material, cotton, what imported cotton, something you use, that fly liberation will not be more. So you may not require that much air change. Dust level will be less. So you can manage with that. Whereas you are having more dust or more contamination more in the some cotton, so there will be fly liberation will be more, dust level will be more. That places you need to maintain the necessary air changes. So this air change decision not only by the designers, not only by the suppliers, not only the maintenance electrical people or maintenance department who is looking after the edge plants, but it is it is the production people and quality people should get involved in informing or giving the correct feedback whether this is working well. Because we keep on giving the humidification, working the humidification plant, still they will tell that we are not able to get the air changes. There is a lot of fluff is accumulated, a lot of breakage is happening because of sufficient air change is not there, distribution is not there, they will tell. So we have to get the information exactly from the production people and quality people. Then only we can reduce the fan speed or change the conditions inside. Because unilaterally, if you do, they will tell that there is your loss of production. Our ultimate aim is efficiently run the plant. Not only energy saving, efficiently. You at the same output, we should get less energy. As engineers and as a technical person, our aim should be to get the better results with minimum energy cost. For that, we need to understand what is the requirement of the customer. See what happens, they may not tell this. We have to find out. Some information is not given. We have to find out whether it is because of the air changes we got this this production problem is coming. Suddenly you set particular air changes and everything fine, working will be fine. Suddenly they will change the product count and mixing, everything they will change. So suddenly there will be some disturbances in the process. Immediately they will tell that it is due to the proper improper air changes like that. So you are reduce the air or because of that only is happening. So when we go for energy conservation, when we change the blade angle of the fan or reduce the speed of the fan or multi-fan system, if we change, we have to consider everything. There should not be it should not backfire. As so so thing is, as Ashok sir has clearly told, it is not only with the energy, is not only the electrical department, it is from the top management. They should say we want to spend the power, we are ready to spend the power, but we want to ensure that minimum our requirements are met, not at the cost of production or our minimum requirement. If you keep on reducing the power just on the sake of saving the power, you will end up with quality problems and other problems. Even it will affect, air changes will affect the productivity, not only the machine, for people also. They will get more sweating, they will feel uncomfortable, absenteeism will be more, and you will put some other new trainee, so he will not perform properly. You may be having one set of people who will performing very well. So these problems will come from the energy point of view as well as other point of view. I am telling this. So finally, what is the efficiency of the, how to see the efficiency of the plant? Normally everybody wants 100% efficiency, which is not possible. So close to that we can get. So it is based on your equipment, the plant equipment and all. What are the equipments you put inside the plant? That will give the efficiency. So basically, your dry bulb temperature of the entering air, that is the location, which location you are going to, your factory is working or you are going to install the plant. So that place, what is the dry bulb temperature, mean dry bulb temperature, and what is the wet bulb dry bulb temperature after the air washer, what we are trying to achieve. So if it is a 42-degree dry bulb and wet bulb of 24, after the air washer, if we are able to get 43 minus 24, that is the RH and dry bulb we are getting. After the air washer, we should try to get close to wet bulb, that is 24, close to 24. If not 24, you should get 25 or 26. So that one minus divided by dry bulb minus wet bulb. That is what wet bulb. It is goes in the adiabatic saturation process. So wet bulb will be same. So if you check that dry bulb, outside dry bulb, and after the air washer, what is the dry bulb of the air washer? These two divided by what is the dry bulb, wet bulb. So if you take the reading and check, you can see the plant efficiency. What is the efficiency of the plant? If your plant efficiency is lower, if it is 80%, 70%, then your whatever the achievement of the dry bulb temperature, it will not be close to your bulb temperature. It will be higher. So almost when outside is 43 and 24, you should be able to achieve 24 and 25. If not, if you are achieving 30 and 24, 32, 24 means if you send the air, that may not be sufficient. Again, you will not able to, you will be wasting the power and you will not achieve the because of the poor spray. There will be number of reasons. Because of the poor spray, proper mixing is not happening, and your distribution is not happening. Some plates are open, some eliminators are not proper, it is all blocked. So many reasons to find the so many reasons for the inefficiency of the plant. Even water spray also, this much liters of water to be sprayed for this much of air. So that mixing has to be done properly. If the pressure is not there, water pressure is not there, the water will be delivering the required quantity, but it is not at proper pressure. It is low pressure, it will not mix with the air. You will be consuming power in the motor, in the pump motor, whereas you will not get the benefit by way of efficiency, better efficiency. This problem will arise. That is why the plant efficiency as well as the air balancing and total air changes and efficiency. These three, if you are able to visualize and find out the reason for inefficiency and find out the reason for unbalance everything, then you can easily solve your power problem and other issues. So basically, if you want to find out the brake kilowatt of your fan, then this is the brake kilowatt, that is shaft power of the fan. Q is the volume of air, and total pressure of the air, and by factor 6120, you multiply with the efficiency of the fan. So here only the efficiency plays very important role. Your efficiency is less, your brake kilowatt is more. Your efficiency is more, this brake kilowatt comes down. and again your motor efficiency also should be more. So how you select your good efficient fan. There only there are a lot of scope in improving the efficiency, selection of the fan, retrofit, everything. In our textile industry in India, there are a lot of mills which are running with old propeller type impeller, 4 blade and low efficient fan, and motors also. They whenever there is a they want to save energy, immediately they go for high efficiency motor and fix the motor first, whichever easiest possible way they will do it. But what about the fan? That will be working at 55%, 60% efficiency. It will be working. Again, there is no point. Your power will be more. So if you improve you retrofit the fan with high efficient fan, really you will save energy. So to know that even energy audit or electrical or maintenance people, when you go for their reducing the power in the plant, first we have to see what is the customer requirement of your RH temperature, air balance, what is the total their requirement. Then what type of fan they are using. If it is existing plant, what type of fans they are using. If it is a new plant, we have to explain them better efficient fan, better efficient fan and best efficient fan. If you give, the total running cost will come down. So such a way we should know what are all the equipments involved. That is why even motor pumps also, this much liters of water it is pump will be delivering at particular head. So that head and quantity is arrived based on number of nozzles and your plant design. So that we need to find out what is the exact thing happening in the plant, why it was selected, whether there is a scope for improvement. If it is already there is a pump, is there a scope for improvement for increasing the efficiency of the pump and fans. So in the existing whatever the fans, as you all know, or I just want to inform about the how the speed of the fan affects the air volume as well as pressure. So this is the fan loss. So directly the speed is directly proportional to the flow. So whatever the speed you increase or decrease, equally if the fan is giving at particular cmh, if you reduce the speed by 10%, then volume will reduce by 10%. Simple. If you increase 10%, volume will increase by 10%. Reduce it 10%, it will reduce 10%. This is what's directly proportional. Speed is directly proportional to the flow. Whereas the pressure is twice. It is square of the speed. It reduces or it increases. The pressure will increase based on your speed. The pressure will increase 2 times, increase or decrease. That is what the fan characteristic. Whereas power 3 times cube of your speed, the power will vary by 10%. It will 10%. This is a square and this is cube. This is the fan loss. Everybody must be knowing this. If not, I explained that is the reason. So based on your fan, not only the fan selection, best efficient fan, even the fan, whether it is working at particular speed, you want a particular at particular speed only it will be delivering, means you have to run at particular speed. So you have to see the fan chart and run the fan at particular speed to achieve the required power or recommended power. It should not increase, it should not decrease. Again, you increase the flow, decrease the flow. As I mentioned, the flow will reduce the pressure also. The flow, if you are reducing the flow, it will speed. If you are reducing the speed of the fan, it is going to reduce the flow. So flow, there could be a reduction in the flow. Your requirement of your humidification plant, you are designed for peak summer. It is not peak summer. Slightly you want reduce. When you are reducing the flow, automatically your pressure is also going to reduce. Power, of course, you are going to get benefit. But when the pressure reduces, you have to see whether because of reduction in the pressure, whether the airflow, whether it reaches it crosses the duct, full length of the department, it overcomes the resistance. So why that pressure is there means, to overcome the resistance only the pressure is given for the fan. Whether it has been taken care while the design itself is having high pressure or not. If the fan itself, you are replace the fan itself with a low pressure fan, again you try to change the speed, it will be working, it will be giving the CFM, but it will not have the enough pressure, and it will not reach the uh, tail end of your of the department. So it will be, there will be ununiform hot pockets will be there. We are facing the hot pockets in your production hall due to this reason. If you reduce the speed, so you have to see how it is going to help us. So when you reduce the speed and of the fan within the multi-fan system, that you have to see, ensure that all the fans are evenly done. One fan this week, and this will be running for 2-3 months. Other fan will be working at correct RPM. So that is also a problem. And also the fan design is such that in axial flow fan, blade angle is there. So the blade angle, the higher the blade angle, it will cut the air more, and it will create the more pressure. So you reduce the blade angle, the free flow of air. Because of that, there is low power. So blade angle as well as RPM and the number of blades, your this all matters in the for the power cost. Your selection based on original selection will be there. So there are two types. One is, nowadays there is no new installation of the mills. It is only a retrofit or modernization of the existing mill that only happens. So mostly utilities that building is used. Utilities are mostly they retrofit all the equipments. But when it comes to production machines, they immediately replace with new machines. So they expect this machine also will perform as per the manufacturer's recommendation. It should perform well, but without taking care of the utility. So we have to see whether this air is enough, whether flow is enough. That information also is as an energy auditor, it is also responsible of energy auditor to collect the information. So ultimately, it is not only saving energy. Energy efficiency should be the maximum. Energy efficiency means for the same output, your power cost is less. So that is what energy efficiency. Wherever possible, by way of equipment, in humidification plant, in air conditioning, the main thing is, you attend from various programs or energy programs, or from different manufacturers, suppliers. They will tell our equipment is highly efficient. This pump is very good. This motor is good. This we can put the VFD is good. All these things they will tell. But unless until you know the system, how it works, how it performs, what is the basic requirement of the customer, which one to use, without this knowledge, we can't solve it. Either from the mill side or management side, or from external consultant side or auditor side. We have to collect the information from the customer. Full information we should have. At what level you are going to run the plant, and what is your required parameters for your best production for productivity, and your requirement, exact requirement. Then based on that, we can recommend what kind of fan, whether we reduce the fan or reduce the speed. All these actions we can take as energy auditor. So you have a different exhaust system. This is what slit drills, everything. You see a neat, very clean department from the. This is on the winding side, on the preparatory side also. So how the exhaust system is designed on the various processes. Like in weaving, it has to take care of what size powder and all. So such a way it has to be located, underground trenches, and that necessary holes provided below the looms, everything to be designed based on the requirement. So when we can go to the fan, what are the different types of fans are there? What is the difference between axial flow fan and centrifugal fan? So he brushed down the fan aspects, expecting me to Ashok sir to dwell a little bit on the fans. I think mostly covered on the centrifugal fans. The type of centrifugal fan he was explaining about aerofoil blades, mostly backward, forward, radial. The four types of impellers are there: backward curved fans, radial fan, forward curved fans, and aerofoil blades are there. Aerofoil is most efficient one. So backward and radial, that efficient chart I'll explain in the next slides. This, if you take the axial flow fans, we have three types of fans. One is vane axial, then tube axial, then propeller fans. Propeller fan least efficient, vane axial most efficient one. So this selection of the fan is important. Not only finding the power of the H plant, to know which there will be two plants, identical plants you would have seen, and you would have taken the reading and power calculation you have taken for the particular mill or process. But you need to note which type of impeller fans that they used. So it is not that only they select that factory was better efficient like that. So we have to point out which fan they used, which type of fan they used, where there is a possibility of increasing the efficiency. So vane axial, tube axial, propeller fans are there. If you see the radial efficiency will be 72 to 79%. So for high pressure, medium, low, and various industrial applications, radial fans are used. Forward curve for material transport dust, we can use the forward curve fan 60 to 65%. Backward curves are used for other clean air fans and for forced FD fans in boilers and other things they are used, 79 to 83%. So aerofoil type, it's the best efficient one, but mostly it is for clean air application used. Here in textile system, what happens, if you select the aerofoil type fan, you have to ensure that dust levels are reduced. That means your filter system should be perfect. So not only your fans, when you change the fans, not only look into the fans, you see the total system. What type of filter they're using, what type of filter media they're using, what is dust level, how they are arresting the dust, what is the maintenance aspect also. As Sir was telling, Ashok Sir was telling, what is the maintenance when they are doing the maintenance, what is the schedule of the maintenance. Even he was telling about the grease and the oiling, like that in H plant, what schedule they are doing the maintenance when they replace the filter media. This is very important. The time they replace the filter media, if they are not replacing filter media, you get choked, then there starvation will occur for the fan. So fan, there won't be any air for the fan. So again, it will go outside your good characteristic of the fan. Again, power will be more, and you will not get the output. So this factor, when we are collecting the plant audit, we do the plant audit as well as from the energy point of view also. Plant audit means generally totally how the plants are working, what is the schedule, maintenance schedule, when they replace the filter media, when they will change the blade angle, like that. All the data we collect, and also data log. What RH they maintain? They tell we try to maintain this. You ask for your data log sheet, then you will know. They will just tell, when you go for the meeting, they will tell we are maintaining this much hour, this much hour. In summer we are facing problem. What we are facing problem? If you collect the statistics, you collect the real time data. You have to collect the real time data, whether by form of the computer printed sheet or by normally still they write in the log book. That if you scan and if you see, you will come to know where they are practicing, where there is a real problem. We can find out whether precisely they are maintaining the RH or not, and where they are compromising, where there is a possibility of saving the power. So as an energy auditor and plant audit professional, we have to collect all the information. No information is unimportant to us. All the information are important to us. So the report may have a lot of information. You collect the information, but when you are preparing the report or when coming to a conclusion, this will help you in better way. So in axial flow fans, propeller fans are best fans. So maximum the propeller fan is the least efficient fans. So in cooling towers and other places used, so 45 to 50%. In many mills, these propeller fans are working. Tube axial, you have a tube surrounding the impeller, and it will have a distance of 1 meter like that. So it is also a good efficient fan, 67 to 72%. This is also mostly used. And this vane axial fans are not much used in the our application. There is a very good scope for changing fans to vane axial fans, because vane axial, you have guiding vane in the head side or tail side of your fan. So it will guide the air movement without turbulence, smooth movement of air. When it guides, the efficiency improves. So if you are going to study the performance of your humidification system, when you want to see the fan, how the fan, as in centrifugal fans are told, when there is a fan, you open and see what type of impeller, whether it's a backward curve, which curve you open and see. Like that, you have to see what is the you have to take the reading, measure the existing volume, and see the fan clearance. This is very important. As he also mentioned, fan clearance between the fan casing and impeller. The clearance is very important. The lesser the clearance, more the efficient the fan. So that from maintenance point of view, people think that okay, we keep there is a gap is more, there is no problem, but there is more gap. Even some places we can see the in the axial flow fan impeller to casing, even your hand will go inside. That much gap is there. That means totally you are wasting the power. The only impeller will be rotating. So your efficiency is based on that, as well as bell mouth from the supply side and from the outlet side also. When you have a cone for the air movement, for the path, the bell mouth cone is fixed on the supply supply side of the fan. It will improve the flow of the air, it will improve performance also, and that is a saving of power. Definitely there is a good saving of power. So flank clearance, pitch angle, I think somebody switch on the mic. So pitch angle is there. Then drive arrangement, pulleys and belts. Of course, some expert on the belts is going to talk, I think. So what is the pulley and belts? If it is a belt drive, what impact is going to take on your slippage loss and achieving the designed RPM. So that drive arrangement, mostly in axial flow fans, if it is better, you have a direct drive arrangement. You change the blade angle, have a direct arrangement. So when you go for belt drive for axial flow fans, there will be a shaft, there will be a pulley, two pulley systems will be there, belt drive will be there, and there will be a slippage loss will be there. So that mostly in supply air and the humidification system, it is mostly used as a direct driven fans only, mostly. So earlier days it was belt driven, so that is mostly. So you have the only option either by changing the fan speed by frequency drive or pulley or by blade angle. You are reducing the power. This is the only option available for the direct driven fans. So inlet and outlet condition, as I told, the bell mouth smooth curvature. You have a fixed cone, outlet also cone, so it will improve the performance of the flow. And what is the operating condition? So it is very necessary to find out the fan operating condition. What is the path load? What is the peak load? Maximum peak load at particular RPM and full plant when it is working. What is the conditions during that time? That data we have to collect, real-time data. Whatever I'm telling is all real-time data. So in the fan, based on your flow and your static pressure, power will play a role. So free air delivery is there, means there will be a lesser power, because mostly we have to try to attain the free air flow after the fan. So it is a closed system. We can have always we have to check for how the outlet is given after the fan, how the outlet is given. Of course, in the supply air fan we can't do anything because you have a duct design. It is going in the exhaust system outside of the fan. If it is near wherever the possibility, after the fan, after the cone, if you provide the exhaust dampers, it will easily go. It will be thrown out easily. And if the shaft is very high, about 10-20 meters, like the 30 meters, it is going, means then there is a shaft and air is going, taking a 90-degree turn and going. So that all those things we have to see. So at best operating point, which operating point we can operate the fan, that we have to decide based on whatever given by the fan manufacturer, or we have to find out if the fan is designed to deliver this much air quantity at particular pressure. So we have to first run the fan, see what is the volume by measuring with the anemometer. We can take in the humidification plant, we can take after the eliminator, we can find out the area. Of course, volume of air is nothing but area by speed of the air, that is velocity of the air. So area in meters or feet, we can collect, we can get the area and the flow path, and we can find out with anemometer what is the speed of the air coming in meter per second or feet per minute. So after average velocity we have to take. There will be, as I told, there will be a turbulence in the air. So the average we have to take. There will be some places there will be more velocity, some places less velocity, like that. We have maximum number of readings we have to take. On an average, you can find out what is the velocity of the air. Multiplied by that the area, you will get the volume. Then for pressure, you have to insert a U-tube manometer in the supply side of the fan, where it is collecting the air. That place, you put a U-tube manometer, you can see the what is the water column. The fan is creating the pressure. So that is, then outlet also, if possible. If you have a very good meter, then you can check the outlet also if it will show the positive pressure. So there will be negative pressure before the fan. After the fan, there will be positive pressure. Put together, you get the total pressure. So once you found the total pressure and the volume of the air, then you can you have velocity of the air. Then you can find out the total volume, and you, of course, you can collect the reading from the motor reading. What is the RYB current taking, motor is taking with the voltage and power factor. You will know the kilowatt what is taking. So for that particular kilowatt power, how much air it is delivering at what pressure. So based on that, you know the Q, and you can find out the efficiency of the fan. So efficiency of the fan you can find out, but that is in practical point, what I am telling is efficiency of the fan, but that is not the correct efficiency. As AMCA standards are there, American Air Movement Control Association. There is a particular testing standard for testing the fan efficiency, flow and pressure. There is a different standards and method are there. You have to collect the standard ducts of 2 meter, 3 meter in the inlet. Then you have to put a pitot tube to collect the information on the total pressure and static pressure, all these things. Then you have to arrive the this much dia of the duct with this much velocity air should go at the time what is creating. Like the fan manufacturer has to do. If he is giving a certified fan, if he is declaring that our fan at particular RPM working for this flow and this pressure, it is taking this much kilowatt, means definitely they will do the testing, fan testing. Then only they will supply to the customer. They will do the fan testing. If it is by a copycat, just by same fan, you put a casting, pressure casting or die casting, if you do one simpler thing, then they will not be able to give the fan chart and other things. So it is a must. In HVAC application, HVAC, heating, ventilation, air conditioning consultant application, consultant insists for fan curve and fan chart from fan suppliers. So that is a must. If you have that fan chart, based on that, you can easily find out what efficiency it is working. So this is a case study, small case study I just want to mention to get the overall information about the conservation of energy through the air washer chamber. So we have done modification in plant A and plant B, name it. So capacity of 85,000 cmh, the air quantity. So both are blow through type. Blow through means before the air washer, the air fan will be there. So it will be blowing the air. So, and size of the air washer chamber, the width 3,500 mm, width, height is 2,700 mm height, and length of the chamber is 4.5 meter length. So chamber length is important because the air and water mixes, no, that has to some time to travel. Then only it will increase the efficiency of spray efficiency. So that length of the chamber and type of air distribution. As I told earlier, this is a retrofit project where GA distribution, old GA distribution plate, there will be a sheet of sheet place, there will be holes there. So air will be going through, 50% of the air will be going through the holes. So there will be a resistance for the airflow. So that we converted into PVC louvers, air intake louvers, what I shown in the photograph, blue color flow intake louvers for the even distribution of the air before the chamber. So then a number of spray banks were, 2 banks were there. Spray pipes were GI pipes earlier. So GI pipes, normally there will be a scale formation, other things will be there. So for that UPVC pipes, we converted the UPVC pipes. And number of spray nozzles were 96. Why it is 96 to 144? We converted the single bank, two spray bank with a single pump. We converted into two independent spray bank with 2 pumps. So air velocity was same. So we didn't change the fan. but only distribution plate we changed from sheet to PVC louvers. From fan volume, almost it was increasing. Fan volume was increasing slightly. The velocity was increasing because low resistance for the louvers. Then total fan pressure was, so because of that it improved. So fan size was 1200, both the fans, 8 blade fans, two numbers, and installed fan motor was 7.5 kW. Pump capacity was single pump with 1125 liters per minute. It was installed earlier with 24-26 meter per head. Whereas we installed 2000 liters of pump, two pumps installed, each of 5.5 kW. Instead of 7.5 kW single pump, we installed 5.5 kW two pumps. So based on this is normally not done in any this type of calculation. See, treated air, after the air washer, treated air, what we get per hour per kilowatt, it is not. So this we calculated to almost 3000 meter cube per hour per kilowatt. This much air is it was delivering earlier. After we changed it to two pump system with slightly higher kilowatt with two pumps, the air what was delivering, the delivering per kilowatt was more. For single pump it was 3857 meter cube per hour, whereas for two pump it was 3052. Slightly marginally it was increased for two pump, but if you see how it was working, two pump was working only for 4 hours, balance 8 hours single pump was working. So because of that there was 19 kilowatt saving in a time of 8 hours, 12 hours, morning 8 to 8 p.m. So 19 kilowatt power was saved by changing this, the modification in the spray system as well as. So like that, the air washer, what is exactly required of the customer, what is exactly required pump, the flexible operation improved the performance. This is what. So if you see the intake air and what are the temperature we have taken, what is the temperature, dew point temperature, what is the relative humidity, what is the air wash efficiency achieved earlier, what is achieved, now it was achieved. So based on that, air wash efficiency improved more, 93%, like that, almost 93% from 80%. It was earlier 80%. So this kind of modification was done. So this was the spray pump, and this is one pump, Ibarra pump, the high efficient pump. They are giving pump even up to 90% efficiency. It is total efficiency we are getting in the pump. So it's a perfectly made pump. It's all robot manufactured pump. So can I go for conclusion or we go for question answer later on? So I'll just conclude, I think. Okay. So the just in the energy point of view and total best practice on the humidification. First thing is we have to evaluate the original design. Then what was the installation plan and compare with the existing operation. So there will be change of machine, change of operation, everything. First we have to do that. Then compare original machine layout. We have to get, wherever we go, get the machine layout first. Get the machine layout, match with the what exactly you see physically. You have to see, walk through the plant and see what is the machine layout, whether machines are correctly current as per the machine layout, and machine performance. Many adjustments done after it has been installed. Speed adjustment, normally they run at particular speed, they will tell now they have changed after they installed, they change the speed, they change the pressure and volume. In case of waste collection system, your carding and other machines, the pressure and all they'll change, volume and all change. Volume is very important for your humidification plant, because your say a single fan, double fan, they put extra pneumofil and compact air. Suddenly they put compact air separately, they will be installed. Original layout, you will see only 12 machines of ring frames. Suddenly there will be one box above that in the plant, that nothing will be there. When you go there, that will not be included. If you see, there will be compact air, additional air, so that will be going out. That what is the air quantity, how many they installed, that also we have to see. That is why this, and what kind of drive, maintenance and service, as I explained, the maintenance, how the maintenance matters in changing, replacing the filter media, as well as the machine maintenance also when they stop. Then revisit the heat load estimation, total heat load of the H plant, you have to revisit it. So 20 years back they designed the plant based on some dry bulb, wet bulb. So even meteorological department also we have to collect the information. Previously they declared 43 for Pune, or for this place. Now it may be 46. They recalculate and they would have published meteorological data as average dry bulb temperature 45 or 46. So based on that, if you calculate CMH, we require more air quantity, more water, etc. So that we have to heat load estimation. We have to see and compare the surplus and shortfall. Whether it is shortfall, it is a surplus. Then analysis of equipments like fans, pumps, dampers and all. We have to see number of dampers as well as the phase velocity of the damper and phase area. They will be given 4 damper, 5 damper. What is size of the damper? That is important because that much airflow has to go through the dampers. And how the leaves are placed, whether opposite blades or opposing blades or parallel blades, that also we have to see. Filters, what type of filter they used. That is also very important because each filter will add power resistance. So each type of filter used, that also we have to see. Monitoring, measuring of air volume, pressure, inside temperature, and RH conditions. Of course, whatever is achieved. Then plant performance, the efficiency, power consumption parameters, and then overall recheck the insulation material. In the next slide, I have shown the recheck the insulation material and reflector coating wherever possible. The coating, you see the air plenum. Plenum should be coated. There should be insulated. It should be insulated. It will be plant is perfect. It will delivering distribution losses where it occurs immediately. It occurs in the plenum itself. It will be exposed to the sun, direct sun. So that wall will be just cement plastered. That directly almost in daytime 8 hours there will be sun will be falling in the wall. That in that plenum. So it totally lost whatever humidification you will become waste. So that place, whether it is possible to put a insulation or you paste it, plaster it with some thermocol insulation, or you do with a paint reflector like that. Then retrofit multi-fan system. If you are having single fan of 30 HP, 40 HP like that, kilowatt single fan, if you are able to change it, retrofit multi-fan system, it will be better. First, if it is possible, because you are having flexibility in operation. Same way as I told in multi-pump system, you have flexible operation. With single pump, you are able to achieve the RH, and whenever the peak time only, you switch on the next pump. So that much power is saved. Otherwise, the single pump, you will be just throttling the valves. So inspect the false ceiling and improve the attic space cooling. Attic space cooling is very important. After the false ceiling, from the roof, there is a gap. That place, if you do the better cooling, your solar heat radiation from the sun, it reduces inside your factory premises, so that you will be able to maintain a better dry bulb temperature and RH. Retrofit with energy efficient motors. Of course, everybody knows this. Almost energy efficient motors, everybody trying to replace with the energy efficient motor. So retrofit high efficient fans. This area there is a lot of scope. Then pumps, changing with pumps also a lot of scope. Direct driven system also I explained already. So direct driven system wherever is possible. Otherwise there will be a slippage will be there if it is a belt system. Maintain less slip with the belt drive system. How to reduce the slip of the belt? Types of belt, that are cogged belt and different belts are there. I think one more speaker is going to speak about the belt drives. That will enlighten all of us with the what type of belts, which is best apt belt can be used for your drives. So reassess the capture velocity. That is also very important. We are seeing the floor grills, everything. If the in the factory, if you see, there will be original design of 8 floor grill only. Somebody says here I want some air, some waste is going. So open that one, put one more grill. Finish. You spend some 2,000 rupees, put one more 1,000 rupees, put one bill. Like that, some temporary measures they will be doing. So when you calculate, you see 10 bills, 12 bills will be there. These are all extra. Over a period of time, they would have painted. You will not know what is original design, what was later. So reassess the entire recapturing. So you will know the with velocity whether it is proper or not. So that so if it is a existing plant, you can collect the drawing or you yourself calculate. So ducting system, revisit ducting system also very important. Duct insulation, all these things in old plant, if you see, they put the duct and insulation very old. So that insulation material would have gone out. So you have to, without that, then so you will be exposing to the attic space. So temperature difference will be there. Whatever you run the plant, run, they will not switch off. They will not allow to change the frequency 50. No, even that we are not getting the RH like that. So we have to inspect. If you see, there will be problem in insulation. Simple. Then descaling, this maintenance. The spray pipe, no, there will be 40 mm pipe. If you see, there will be 10 mm scaling will be there. They don't do the maintenance. They will tell there is no time for maintenance. You have a spare set and you do in the third shift, that is early morning, in the night 1 o'clock they can start replace the pipes. That they should do. Like that, if they replace, then descaling to be done, soft water and insulating water tank. This is also more important. The when the peak summer, when you are putting the spray system on, water will be consuming because of the outside dry air. If it is a dry air nature, water keep on consuming. To replace the refill the tank, that time they will be taking, that time only they will be taking the hot water from the overhead tank. That will already will be hot. That you will take again, you are spraying the hot water. That means you are heating and humidification. They will do instead of cooling and humidification, they will be heating and humidification without knowing, because hot in the pipes, they will see the tank, oh, water is reducing, some operator will not be there, water is reducing, float will not be working, so they will suddenly remove the water valve. So hot water from the pipe, already it will be running for 100 meters, that pipe already hot, that pipeline water will be hot, and also over tank also will be hot. That hot water will come in peak summer, they will be doing heating and humidification. This all practically I have seen. So pressure monitoring and control system and automatic control system, and how building management system is done, this is one big subject. One day we have to talk about automatic control, how automation to be done in the plant, in the particularly HVAC humidification system. Then monitoring, recording of all energy parameters, as I told, each and every individual motor, what was the power factor, what was the power factor, what was the frequency, for each and everything we have to collect information. That not assumption. They will tell after they do the visit, they will tell over phone, they ask what was the power factor, what was the voltage, like that. We have to read it, then we will find out easily. This is what total, I think, wherever the area of improvement and basic heart of the humidification, where we can improve the efficiency, where we can improve the operations, where the requirement of the customer. I think I have given highlighted all these things, if not in detail, at least I have given interest. I created interest to the participant on the very aspect of textile humidification, so that next time you go, you concentrate more, or you try to get more information. And I think your assessment or your audit will be better than whatever was earlier. Even if you are first time you are listening to this, your understanding of their concept of humidification on textile manufacturing also would have increased your interest. This is what I want to finish my my lecture on this humidification. So any questions, I am open.
Is there any question from participants? You can ask directly, or you can type in the chat box also.
Any questions? I think they don't want me to disturb their lunch. So everybody is hungry.
No, sir, you have lots of knowledge. We have to go through all the things, whatever you have said till now, sir. Thank you.
Okay. Thank you so much, ma'am.
Highly informative and very practical. And what is happening in the textile mill, you have told us. Thank you, Mr. Prakash.
Yeah, thank you so much, sir. Thank you so much, sir. So as you told, I have to focus more on the fans and the other areas, because generally I don't want to tell about the equipment. It is available in the market. You go to Google, it is available. So I don't want to tell about this HVAC as far as humidification and air conditioning concerned. It is more on the design aspects where we fail more, based on the cost consideration also.
Hello, sir.
Yeah, please.
So, sir, in textile mills, which type of motors commonly you have to use in mills? All the mills, like this?
Type of motor means it is. I'm not able to understand. It is in terms of cooling, or in terms of foot mount. Normally foot mount and four pole 1440 RPM only they use. 1440 rpm,
Yeah.
and continuous rating, and there are lot of parameters for selection of motors. For what application you want to select the motor, if it is a continuous rating, or if it is your temperature will be more, means then you have to tell ambient temperature will be more for that motor. So based on that, their cooling and their they will select the fan. Even the environment also, based on that, they will give polyurethane coating for the fins of the external. Then bearings also continuous rating, based on that they will give the bearings, load, torque. So while selecting the motor, we have to give. But for machine manufacturer, if it is a OEM, they will select as per their requirement. As far as fans are concerned, normal, it is all continuous rating motors, mostly 4 pole, 6 poles we use. That means 1000 rpm or
Okay.
1400 rpm continuous rating motors we use.
Okay, sir. Thank you, sir.
Nowadays, adaptability of VFD also we have to see for the motors, because the frequency changes there, no. So that while selecting the motor, we have to tell we are going to put VFD. That is also important factor to arrive the peak efficiency, and we should not go for underload of the motor, the selection of motors. I think Mr. Srinivasan will be the right person to explain about the motors. Any other questions? Of course, it is not my area. Just you asked, I just explain whatever we are using in the our plants, H plants.
Any other question?
So my mail ID is also is there, vayutechno@gmail.com. You can just put your questions or any information you want to have. You can send me mail, or you can contact Dr. Sanjay Kaur. He will be helping as a convener. He will be much more interested to pass on the information and get the information from me. So I am also thankful to the organizers, convener, and all the coordinators for the excellent arrangement. I really apologize for the initial glitches, technical glitches. I'm sorry for that. I hope almost 1.5 hours you're able to get some technical information on this textile humidification.
Thank you, sir. I just propose a vote of thanks. I thank Prakash sir for this interactive session. Sir nicely discussed humidification system and energy conservation case studies in textile industries. On behalf of Sharad Institute of Technology, College of Engineering, once again I thank Prakash sir for enriched knowledge of our participants in this workshop. Thank you, sir. Thank you.
Thank you. Thank you so much. Thank you so much. Signing off.
Okay, sir. Okay.
Then we'll join the afternoon session.
Yes,
what time
yes.
is the announcement is there? Afternoon session?
Yes, yes. Our next session we will start at 2 p.m. sharp.
Okay. Thank you.